This is Hao Liang. For this week KNIME challenge, my topic is Titanic surviving prediction. The datasets come from Kaggle. It's an official dataset, originally from Kaggle team. It contains three datasets: gender submission, test, and train datasets. Both are in CSV file. There are total 12 attributes for test and train datasets, and for train dataset, it contains 891 instances, and for test dataset, it contains more than 1000 data. This is what our train dataset looks like. It contains both categorical and numerical values. Some of the categorical value may look like numeric value. For example, survived. It's our target variable or target attribute, but it's actually a categorical value. Like 0 means lost survived, 1 means survived. For other attributes, the P class means the ticket class, and SP means number of siblings, spouses on the Titanic. Part means the number of parents, number of children on the Titanic. The embarked means where the customer went on Titanic. As you can see from the spreadsheet, some of the attributes are not relevant to our final target, which is whether they survived. For example, I don't think where the customer went on Titanic will affect their final chance of surviving. So we excluded them. We excluded the ticket class, the number of siblings, spouses, number of children, parents, and ticket number, name, fare, and cabin. This is what my KNIME workflow looked like. It used line elements. Like there are several stages, including data cleaning, preparation, and the final algorithm performing. After import our data using the CSV importer, we can see the statistics to have a first look of our dataset. The KNIME is very convenient. It supports all the statistics we need on one graph. The second element is the missing value. Like you can see from the left spreadsheet, there are some missing values. Next, this dataset is the raw data of the Titanic, so some of the people we don't know how old are they or what cabin they are, but we will not use cabin since it's not relevant to our final target. So we use the missing value element to help us with that. We use the mean of all customers' age to replace the missing value for age column. And number to string, like we will exclude some of them, like fare, the ticket price, and the domain calculator. Like we set the original restrict number of possible values was like 60, and we set it to 120, and by comparing, like the 60 will not work, like 120 works and has a very good result. And for the right graph, you can see for partition collected to random forest learner, use the triangle to collect, and for random forest to learner and random forest learner to predictor, they actually use square to collect, since the square means output, so we use output to collect to the next element. And for partitioning, we use the relative partitioning, and I tried several partitioning here, include 60, 75, and 80. And I finally found that 80 performed best with 85% accuracy. And this is the algorithm we preferred, the random forest. It solves the regression and classification problems, and it's like what we learned in previous class, the decision trees, but this one contains like many decision trees. It reduces the overfitting and improve the accuracy comparing to like normal decision tree algorithm, and it's very efficient for missing value. And this is our random forest learner. As you can see from the graph, it contains like many decision trees. And this is our random forest predictor. Like the left one is the original spreadsheet, the right one is the outcome of the predictor. You can see from the very right column, the prediction. It means of chances that this customer will survive. Like for the first one, 0.68 means like he has like 68% of chance to survive. And we can see he actually survived. And after like comparing different settings, we got our final result, which with accuracy almost 85%, which is very good, I think. And the number of correct classified instances is 152, and wrong instances is 27. Thank you.